Hello friends, welcome to my channel. My name is Fikret. This video is part of video series dedicated to learning Microsoft Fabric. Microsoft Fabric is a unified platform designed to bring together different workforces within your IT, including data engineers, analysts, data scientists. Uh, Over the last few weeks, we have been exploring data factory service, which represents no-code experience within Microsoft Fabric. So using um, easy to understand, intuitive graphical interface, you could build um, sophisticated pipelines, data pipelines to move your data as well as to transform your data. This service is very good for data analysts as well as so-called citizen engineers who could start building your pipelines right away without spending time on learning languages. Today we are starting discussion around data engineering service, which represents the code-first experience. So this service is best for developers and engineers who know some of the popular languages like Python, SQL, and some other languages. It's very powerful. So it allows you to create virtually any kind of transformation, any kind of pipeline that you can imagine. Uh, Today's session is mostly introductory session where I'll go over core technologies that are part of data engineering service. I will also mention evolution. So I'll also bring brief history of evolution of analytic systems in the last few decades and explain the challenges that led to creation of modern lake houses. I'll also show, I'll also bring some demo which will help you understand how to navigate data engineering service, how to create your notebooks, lake houses, how to navigate OneLake. Before proceeding, a quick reminder to subscribe to my channel if you haven't done so. That will allow you to stay up to date with my latest videos. Okay, so let's get started. Here's a quick preview of what we're going to cover today. I'll start with the overview of data engineering service in Fabric, and we'll explain the core technologies that are part of this service. Then I'll move on to discuss Apache Spark, which is one of the most popular analytics technologies today. Then we'll have brief discussion of evolution of analytics systems, and I'll mention some of the challenges that led to development of modern lake houses. So we'll start with databases and talk about data lakes, Deltalake, and finally we'll cover Lakehouse. We'll have quick discussion around Medallion architecture. That is a recommended architecture when you are building your lake house. Then we'll talk about Lakehouse implementation of Microsoft Fabric. I'll explain what is OneLake Hub and how Lakehouse and the OneLake Hub are related. Next, we're going to move to demo, where I'll show how to navigate data engineering service. how to create lake houses using sample data, how to navigate one lake hub, uh, different parts of one lake hub, and explore your data. We'll also take a look at notebooks, which are uh, primary method in primary tool of creating pipelines within data engineering service. I'll show you how to add your code, how to run your cells, how to visualize your data. Finally, we'll take a look at different endpoints available in the data engineering service. So we'll take a look at Lakehouse as well as SQL endpoints. Data engineering service within Microsoft Fabric represent code-first experience where you create pipelines using your notebooks, job definitions, etc. There are a few core technologies that are at the base of data engineering service. These are Apache Spark and Lakehouse. Let's take a close look at Apache Spark. Apache Spark is open source big data platform based on Hadoop, and it was introduced in 2009 to address certain Hadoop challenges. So in contrast with Hadoop, Spark has in-memory engine, which makes it very fast and much more performance than Hadoop. Like Hadoop, Spark is also based on distributed computing. It works on cluster of computers. Unlike Hadoop, Spark allows interactive SQL queries. It also includes structured streaming, which allows you to build low latency real-time pipelines. Finally, Spark also includes machine learning libraries like MLlib, which works on distributed clusters. Let's talk about programming languages. As I mentioned, in data engineering service, you create notebooks, and you can use multiple languages within this notebook. So one of the most popular languages is Python. So it's variation of Python called PySpark. Then there is a Scala language. You can also use R, and you can use SQL, which is also called Spark SQL. I'd like to bring here a brief history of analytic systems evolution so that it will be easy to understand the challenges that led to creation of modern lake houses. I still remember times when data warehouse were built only on databases. That's where on-premise databases like Oracle or SQL. So these databases were very good on storing and processing structured data. They also were good on handling ACID transactions. So basically, they took care of data integrity. They allowed high concurrency, which meant that they were very good on transactional for as well as analytical queries. Um, However, as the data volumes grew and as we world started seeing more and more big data volumes, um, shortcoming of this database-based warehouses became apparent. So one of the biggest shortcoming was they not ability to scale well. Of course, you could create this data warehouses in powerful machines, but at some point, these machines were not sufficient. And then these databases were mostly designed to store structured data, and with organization having more and more unstructured or semi-structured data, this became a problem. Finally, these database systems were not very good on ingesting high velocity data streams, which required a low latency. And finally, most of them were based on proprietary technologies, which created challenges when organizations wanted to migrate to other systems. The next stage in this development was introduction of data lakes and the cloud systems, which solved multiple problems. Well, first of all, they allowed unstructured data alongside with structured data. They could also allow much larger volumes of data amounts, so practically unlimited amount of data, because storage has become cheap. Data lakes were also good to store high velocity data streams. However, data lakes had some shortcomings as well. Um, the biggest one was that they did not allow modification of data. They were mostly append only. Um, no schema enforcement was another shortcoming. So although systems like Hadoop allowed you to store the metadata schema for the data, these were read so schema on read, meaning that this schema did not prevent irregular data arriving to your system, which in turn led to so-called data swamps, where uh, organization had many uh, uh, data artifacts that did not comply with expected schemas or structure, and that brought to low quality and the loss of confidence in the data. Data lakes were also not good for ACID transactions. So they were not, because did not allow the modification, data modification, they were also not good for in handling ACID transactions. The next stage in the evolution of analytic systems came with the introduction of Deltalake. So Deltalake, on top of existing data lake advantages that I already mentioned, Deltalake was also based on open source, which was a big advantage. Besides that, Deltalake allowed to modify the data. You could apply um, commands like delete, modify, and merge, which in past you could apply only in regard to database tables. Deltalake also allowed schema enforcement. Now you could set schema and ensure that all the data arriving complies with that schema. Finally, Deltalake also allowed ACID transactions by taking care of data integrity and allowing some concurrency, ingestion concurrency. Um, I should mention that Deltalake also has shortcomings. It's not suitable for OLTP systems where you could expect a high volume of transactions, modifications and transactions. So this is mostly for, Deltalake is very good mostly for analytics. Here is how Deltalake technology works. So it's based on Parquet files. And it creates multiple versions of the files with, as you modify your data. Besides that, Deltalake also creates a folder with transactional logs. So those are JSON-based logs. I provided a sample file here. And this transactional logs in turn allows you to do time travel, and go back and see what was your database or what was your tables at some point in past. The last stage in this evolution came with introduction of Lakehouse. So this is relatively new concept, which includes unstructured data alongside with structured data. Uh, so when I say unstructured, this could be image files, audio files, or semi-structured data. A Fabric implementation of Lakehouse accordingly have two sections which we'll be discussing in future videos. So that's unmanaged, where you can store any type of data, including structure and unstructured, and the managed section, which includes only structured Delta Lake tables. So OneLake hub is a kind of central place in Fabric where you could create many different lake houses and link them using so-called shortcuts. So that allows you to refer from one database to another easily um, without worrying about creating credentials or authorization. Since we talked about Delta Lake and the lake houses, it's worth to spend a few minutes to describe medallion architecture, which is recommended architecture when you build lake houses. So if you follow this architecture, you first have to create a bronze layer, which will consist of tables which would mirror your source. So for example, if you bring data from SQL or flat files, then you would see data as is in this layer. Once you ingested data into Bronze, you would typically apply certain transformations and cleanse your data. You do enrichment, using some lookup values, etc. You apply certain duplication, deduplication, for example, and then you get silver layers. The final layer in this architecture is called gold, which is the data that's ready for consumption. You can also call it curated. All right, I am in Microsoft Fabric, and to work with data engineering service, the first thing to do is to select that service from bottom left corner. So as you can see, we have multiple services. So I'll select data engineering service. And here I can create multiple artifacts. So the most common ones are Lakehouse and notebooks. And we'll take a look at this a little later. But you can also create new environment, which is combination of your cluster settings. We have job set definitions, Spark job definitions that we'll be exploring in future videos. We can use data pipeline. Data pipeline is something that we have looked closely in past videos. Uh, and then you can import your notebook if you have it available locally. Finally, you have use a sample button, which uh, gives you quick start. So I'm going to use a sample button. We'll click here. We'll confirm public holidays data. And that creates a sample lakehouse called sample lakehouse 277. So let's take a look at the available panels here. On the left-hand side, we have Explorer, which shows you structure of your lakehouse. We have two sections here, managed and unmanaged. So anything on the tables considered managed. So you'll find all your Delta Lake tables under this section. And files, any other files like images, sound, or semi-structured file, you can upload to files section, which is unmanaged section. So when you click on certain table, it will show you data sample. You can also expand it and review that structure. If I navigate to unmanaged section, we have subfolders. If I click on one, you will see files inside that. The nice thing about it is that this Explorer is that it allows you to easily explore, take a look at the data, explore the data, uh, which is amazing. So if you click on one of these files, it will show you file content. Similarly, if I go navigate to another subfolder, I will see Parquet and CSV files. If I click on CSV, it will show you content. If I click on Parquet, it won't show the content, so it will say preview is not available for Parquet. On the top part, we have buttons to work with notebooks and to bring the data. Here you can use either existing notebook or create new notebook. I'm gonna create a new notebook. And that will come with the first cell. So all your code within the notebook will be living within the cells. You can easily add cells to your notebook using these two buttons below. So if I click code, this is for code. Alternatively, you can also click on markdown, which would allow you to put some headers, comments, etc., which is very good for documenting purposes. So I'll say exploring data. And I can format it if needed. Now, within the cells, you can type your commands. Alternatively, you can also generate this command if it's simple select statements. So, for example, for this table, if I click on this button and select load data and Spark, it will generate code, PySpark code for your notebook. Now, one thing to notice here is that we have a language selector here at the top. So if I click here, you can switch between different languages. By default, it's PySpark. And here you have environment selector. You don't need to worry about that unless you are intending to unless the existing cluster details or settings are not enough for you. So we'll come back to this setting later. So for now, let's run our first command. You can run it from here, run cell, or you can simply click Shift Enter, which is a hotkey, and that will initiate the command. I should mention that besides selecting your default language from the top, which will be common for entire notebook, you can also select language for your individual cells. So not all cells have to follow the default language for the notebook. So for example, if you click here, you can select to different, you can switch to different languages. So my command has produced data, and I can take a look at its tabular format. I can also switch to some visualization options like charts. So for example, in this case, it produced data bar chart. If needed, I can click customize chart button and select different types of charts. Okay, now let's try running different, let's create another cell and designate it as a SQL cell. So I'm gonna select this statement from here and come here to the next cell and call it Spark SQL. I'll copy paste my statement here, and that will produce same results. Notice that we have this icon here, which is also called magic. So this is simple way of switching between languages. So in this case, my default language is PySpark, but here I am instructing um, Spark to switch to SQL language. You can also type this magic. Once you have included all your transformation logic within the notebook, you can save your notebook and either run it manually, just like I did here, or you can schedule it. So we'll talk about scheduling options in future videos. Let me show some other commands to work with notebooks. If I come to cell, if I click on any of these cells, there are a few other buttons available here. So you can convert this command cell to markdown if needed. You can clear output. So I cleared out my output from this cell. You can put a comment here, which could be useful if multiple people are working on the same notebook. There are some locking, freezing options. And under more commands, you have option to merge different cells. You can hide output. You can move the cell. So for example, if I want to move this cell up, I can select this button. Um, uh, at the top, besides this language selector, we also have commands to run all cells at once, or run certain cells above or below our selected cells. You can do this. You can achieve the same result by clicking here and saying run all above or run this cell and below. Okay, now that we learned using sample lakehouse, let's create a new lakehouse ourselves. So I'm gonna head to home page. Let me first close one of these artifacts that I created earlier. And I can create a lakehouse either from using create button or from here. I'll click Lakehouse, name the lakehouse as that creates empty lakehouse. From here, if I come under files, I can create folders under that. So I click new subfolder, I'll click it, say CSV. And I can upload files from my to this folder from my local machine. So I click here, navigate to upload and select upload files. I can alternatively select upload folder as well if I have more than one file. I'm gonna select this file that I created for learning purposes in the past videos, and we'll click upload. That created my CSV file, and from here I can take this CSV and easily create data for Delta Lake table from it. So I'll click on this button and navigate to load to tables and click to new table. And I have to select file type here, so which is going to be CSV, specify separator, and say use header for column names. There's just few settings that you have to specify when you're working on CSV, and from here it's very easy. Okay, so let's check this manage section. If I click here and select refresh, that shows the table. So you can see how easy is it to create the tables, upload the files without writing single code, line of code. Let's take a look at endpoints. So as you may have noticed, we have drop down box here, which allows you to select switch between Lakehouse and the SQL endpoints. Just to remind you, Lakehouse endpoint allows you to work um, with notebooks, so interact with your data using notebooks, whereas SQL Analytics allows you to write SQL statements against your database. So let me just switch to SQL Analytics. And just like with Lakehouse endpoint, on the left-hand side we see Explorer. This is slightly different. You can see that we have different schema names here in addition to table names. But table-wise, you will see similar information. So you can see table names, column names and the types, and you see data sample here. If needed, you can click new SQL query and type your SQL query, explore your data as needed. Alternatively, you can also generate SQL statement from table itself. So if you select that table and navigate to this button, and from here you can select new query, select top, and that will generate SQL statement for you. Okay, I'm gonna wrap up today's discussion on this note. To summarize, we learned how to navigate data engineering space, how to create Lakehouse, how to look around different sections of OneLake. I hope this gives you idea on how to start. Um, Feel free to put your questions in the comment section. I will be happy to take a look. Thanks for watching, and I'll see you in a future videos.